Hello, let us see the CAMS chapter. In this CAMS, let us discuss about knife edge follower with uniform acceleration and retarded motion, and the roller follower moving with uniform velocity. Recap of the previous lessons. In this earlier lessons, we had discussed about the construction of displacement diagrams and cam profiles when follower moves with both uniform velocity as well as simple harmonic motion. Now in this lesson, the objectives of this lesson, today's lesson, on completion of this lesson, you will be able to draw the displacement diagrams and also to draw the cam profile of the cam when the follower moves with uniform acceleration and retardation for knife edge follower, and the profile of the cam when the roller follower moving with the uniform velocity. In this lesson, these two, that means one follower, knife edge follower with uniform acceleration and retardation, and the roller follower with the uniform velocity. Let us discuss these two in this lesson. So, in this lesson, knife edge follower with, first of all, uniform acceleration and retardation. For this, how to draw the displacement diagram whenever the follower moving with the uniform acceleration retardation. Displacement diagram when the follower moves with the uniform acceleration and retardation. First of all, in this case, same as in the previous lesson, divide the lift into equal number of parts in this uniform acceleration retardation, and first of all, draw a horizontal line which is equal to 360 degrees of cam rotation with the taking proper scale. That means maybe 30 degrees equal to 10 millimeters. Thereby, you will get 120 millimeters should be maybe equal to the 360 degrees of cam rotation. And perpendicular to this horizontal line at the left end, that means point A, let us take. From that, draw a vertical line equal to the stroke of the follower and complete the rectangle by taking horizontal parallel line to the horizontal from the top of the stroke line and complete the rectangle. And divide this rectangle into, that means horizontal line 360 degrees into required stroke length, dwell, and required outstroke, dwell, and return stroke, and also dwell. So after division of outstroke, dwell, and return stroke, and once again dwell, and divide the outstroke part and return stroke part into even number of equal parts, maybe 4 number of equal parts, or maybe 6 number of equal parts, or maybe 8 number of equal parts, or maybe 10 number of equal parts. After division of outstroke into even number of parts and return stroke into even number of parts, draw the vertical lines from each point of the outstroke and also return stroke. After completion of this, up to this level, for all types of motions of every follower is same. After this, the procedure will be different for uniform velocity, and procedure will be different for simple harmonic motion, and procedure will be different for uniform acceleration and retardation. Now in this, at present, we are going to discuss about how to draw the displacement diagram for a follower moving with the uniform acceleration retardation. And now let us take a midline of the lift, that means a midline of the divided outstroke and return stroke, will be divided into mid vertical line will be divided into equal number of parts as divided in the outstroke and return stroke. Suppose if you divided the outstroke into 6 parts and return stroke into 6 parts, the same way the midline of that means suppose 6, it is third part. If it is 8, it is fourth part. Fourth vertical line or sixth vertical line should be divided into same number of parts as divided in the outstroke and return stroke. Right? Now here let us see the same thing started. Divide the lift into equal number of parts and divide the angular displacement of cam for rise or fall of the same follower into same number of parts as that are in on lift. And points A, B, C, D, etc. E, and similarly A dash, B dash to E are obtained, and join these points to obtain smooth curve. So this here is the displacement diagram for example on displacement diagram for a follower moving with uniform acceleration and retardation. So as I told you, this will be the angular displacement line, and this is the outstroke up to this, that means angle of ascent or angle of outstroke or rise of the follower, and here is the angle of descent or angle of return stroke, and in between these two, the 6 and 6 dash, actually this should be the dash, and 6 and 6 dash will be the dwell period, and remaining dwell period if required you can take, otherwise if not required you can't, there is no need to take this. So divide this horizontal line into angle of rise up to 6, and from 6 dash to 0 dash angle of fall or return stroke, and from here it is the dwell period, and remaining will be the another dwell. And after division of these, draw the vertical lines from each point 1, 2, 3, 4, 5, 6, etc. and 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash. Draw all the vertical lines. And now the mid vertical line of these 6 vertical lines, take that is third one, divide this stroke length. This length is equal to the stroke length or lift of the follower or displacement of the follower. Divide this into same number of parts as done on the outstroke as well as return stroke. That means if it is 6, this should be also divided into same number of parts. Say that is, so here it is 1, 2, 3, 4, 5 and 6. Similarly here also at 3 dash vertical line, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, similarly 6 dash. So now let us have, after completion of the division of stroke into outstroke as well as return stroke, and join with this point O or the 0 to 1 on stroke line, 0, 1, and this line will intersect the vertical 1 line at certain point. This is say this point, this is say A. Vertical line of 1 point and 0 to 1 will intersect at this point, that is 1, A, and similarly second vertical line will intersect 1, B, 2 at point B. This will be the second point, and similarly 3 vertical line as well as 0 to 3 will intersect at this point, that is a C. And after this up to third point, midpoint, you have to take from 0, whereas for the next 4 vertical line, 5 vertical line also you have to take from top position. That means from F you have to take sixth vertical point. So from the here point, from this point, draw up to this, you will get fifth vertical line will intersect at this point, that is say E. And similarly, fourth vertical line will intersect at this point. Say if you draw a line, inclined line like this, you will get at this point. The same procedure is to be adapted. The same procedure is to be adapted for written stroke also. So let us see 1, 0 and 1 dash will intersect vertical 1 dash line at point A dash. Similarly, 0, 2 dash will intersect at this point vertical second line at 2 B dash, and similarly C dash and D dash and E dash. Finally, you will get F dash. If you join all 0, A, B, C, D, E, F and F dash, E dash and then C, D dash, C dash and similarly B dash, A dash and 0 dash will give you the required displacement diagram when the follower is moving with uniform acceleration and retardation. So right, this will be the displacement diagram. This will be the displacement diagram, right? If the follower moving with uniform acceleration and retardation. And let us see one problem on this uniform acceleration and retardation when the knife follower moving with that motion. So here is the problem. A cam with minimum radius of 35 mm. It means base circle radius 35 mm and rotating clockwise at uniform speed. So as it is clockwise, then we have to take anti-clockwise direction. So is required to give a knife edge follower. If the follower is knife edge follower, to move outwards, that means outstroke or angle of ascent through 40 mm. The stroke of the follower is 40 mm during 120 degrees of rotation of the cam. So outstroke is 120 degrees and stroke length is 40 mm. And next is to dwell for the next 60 degrees and to return its starting position during next 90 degrees of cam rotation. And dwell for the rest of the period of cam rotation, right? So this is the problem that you have to solve. And here also one thing you must have: the axis of the follower passes through the cam center. So draw the profile of the cam when the line of stroke of the follower passes through the center of the cam shaft and the follower moves during both outstroke and return stroke with uniform acceleration and retardation. This will be the important one, right? Both outstroke as well as in stroke, both will be of uniform acceleration and retardation. Okay, so let us see this problem as we have this given. So here you can see this is the outstroke. A, B will be the outstroke 120 degrees and B, C will be the dwell period and C, D will be the return stroke for 90 degrees and remaining part is 90 degrees, right? So this is also a dwell period. Okay, and now divide this AB outstroke and CD return stroke into 4 number of parts. Say 1, 0, 1, 2, 3, 4 and 4 dash, 3 dash, 2 dash, 1 dash and 0 dash, and draw vertical lines from each point in outstroke as well as the return stroke also, right? After completion of the vertical lines and A and divide this, say midline, say this is the midline. middle line of these vertical lines. So second vertical line. Divide this into same number of parts, that is 4 divisions. So this is 1 dash, 1, 2, 3, right? And join A1, it will intersect at this point. This is place of point 1, and A2 at this point 2, and 4 to this point from top one. This third point you will get the curve like this. And similarly, same procedure is to be adapted here also in the return stroke. That means divide this second 2 dash vertical line into same number of parts and join D1 dash, D2 dash, and 4, or say this is C, maybe C, or 4 dash to 4, 3 dash, you will get another point 3 dash. You will get, if you join all these points, so this will become 0, 1, 2, 3, 4, 4 dash, 3 dash, 2 dash, 1 dash, finally D, and up to here D. This will be the displacement diagram when the follower moving with the uniform acceleration and retardation. Okay. So let us see, based on this, we are going to draw the cam profile. So for marking of the distances, we have to take 1, 1, 2, 2, and 3, 3, and 4, 4. Similarly, this will be the vertical line will be the stroke length 40 mm, and similarly here also we have to take the same distances. So take scale 10 mm is equal to 30 degrees. Draw a horizontal line ABCDE with 360 degrees, and with a suitable scale 10 mm equal to 30 degrees. And AB is equal to 130 degrees to represent the outstroke, and BC represent the 60 degrees to represent the dwell period, and CD equal to 90 degrees to represent the return stroke or end stroke. DE equal to 90 degrees to represent the dwell. Right? So like this you have to divide the horizontal line and divide the angular displacement during outstroke and return stroke into equal number of even parts, and divide vertical lines through 0, 1, 2, 3, 4 and equal to the lift of the valve or follower, that is 40 mm, and divide the vertical lines 2D and 2 dash D dash into the 4 equal parts. The points A, B, C, D and A dash, B dash, C dash are obtained as shown in figure. That is, as I told you already, join these points to obtain a smooth curve. Since the follower moves with equal uniform acceleration and retardation, therefore the displacement diagram for outstroke and return stroke consists of double parabola. Right? So this will give you the double parabola. So, and so it completes the displacement diagram. And now here is the what we call cam profile. Cam profile, how to draw the cam profile. Here you can see, I will explain. With the least radius or minimum radius of the cam as given in our problem, draw the circle with center O. Let's see how much he has given. So 35 mm minimum radius and outstroke is 40 mm. So with 35 mm radius with center O, draw a circle which is nothing but the base circle of the cam, and mark point O and also mark one point A, and draw a knife edge follower from point A which is having the axis for passing through this point O. That is axis passing through the center of the cam. And from OA, mark the angles as the cam is rotating in clockwise direction. We had think that the follower is going to move in anti-clockwise direction over the cam. That's why mark the follower motion in opposite direction to the motion of the follower cam. So as the follower is moving in this direction, we have to mark the follower motion in opposite direction. That's why from OA in anti-clockwise direction, mark angle 120 degrees, which represents the outstroke. After 120 degrees, dwell period for 60 degrees, mark, and also next 90 degrees for the return stroke or in stroke. And divide this 120 degrees of arc into same number of parts as divided in the displacement diagram. That means in displacement diagram, we have divided that into 4 equal parts. That's why here also we divide this into 4 equal parts. That is 1, 2, 3, 4. Similarly, return stroke also 4 dash, 3 dash, 2 dash, and 1 dash. Right? So you have to produce these. That means extend these 0, sorry, O, 1 to produce beyond the 1 point, and similarly second line, third line, fourth line. And similarly here also return stroke also the same thing we have to do. Right? After completion of this division, mark distances from the displacement diagram. That is 1 dash from the 1 displacement diagram, 1 dash. Similarly 2 dash from the displacement diagram, 3 dash. Similarly same as, and 4 dash. Similarly and mark all the points in the return stroke also. After completion of marking points 1 dash, 2 dash, 3 dash, 4 dash, etc. Join all these points from starting from point A, because this point is the tracing point, A, 1 dash, 2 dash, 3 dash, 4 dash, and 4 double dash, 3 double dash, 2 double dash, 1 double dash, and complete the profile. And this will be a smooth curve by hand. This shows the cam profile. This shows the cam profile when the follower moving with knife edge follower moving with uniform acceleration and retardation. So here in this various points, you can say this is the knife edge follower. This point is called point A is called trace point, and this circle is called base circle, and this point O is called center of cam, and also this line is called cam profile. Okay. This is all about this problem. So like this, you can draw first of all, the 2 stages are there in cam profile. One is the displacement diagram and finally cam profile. Draw the prime circle or base circle with radius equal to the minimum radius of the cam, that is 35 mm with O as center, and divide the prime circle such that angle AOB is equal to 120 degrees and BOS angle BOS is 60 degrees and COD 90 degrees. And divide the angles AOB and COD into the same number of equal parts and join the points A1, 2, 3, 4 with the center O and produce this. And also from the points 1, 2, 3, etc. mark off displacements from 1 dash, 2 dash, and 2 dash, 3 dash, and 4 dash measured from the displacement diagram. Now join the points A, 1 dash, 2 dash, 3 dash, 4 dash with a smooth curve. This is the required profile of the cam. With this, we completed one problem. That means a knife edge follower. In the previous lesson, we have discussed about the knife edge follower with the uniform velocity and knife edge follower with simple harmonic motion. And in this today's lesson, we have completed knife edge follower with uniform acceleration and retardation. And now let us go to the roller followers. Roller follower with uniform velocity. That means For roller follower, we are going to discuss about with uniform velocity, simple harmonic motion, uniform acceleration, and retardation. Right? So today, roller follower moving with uniform velocity. Now here also in this case, the displacement diagrams also there, and here also cam profile should be there. And same as the cam usually rotates at uniform speeds, as we have already aware that, so that the equal angular displacement take place in equal intervals of time. So follower is required to start from rest at the beginning of each stroke and come to the rest again at the end of each stroke. So its velocity must be variable. And the period of cam rotating during which the follower remains at rest called dwell period. So this is same as in the previous problem, that is a displacement diagram for uniform velocity. And here also it's the same way. See, AB will be the outstroke, BC will be the dwell period, CD will be the return stroke. Same technique as we have followed in the previous problems also. For uniform velocity, so D will be the dwell period. As it is the uniform velocity, it should be constant. The variability will be the constant. Here it is. So that's why AB is a straight line and CD is also a straight line. And after completing this figure, we'll have uniform, a displacement diagram with uniform velocity, right? So AE, one revolution of the cam, AB during outstroke of the cam, and BC period of dwell at the end of stroke, and CD during the return stroke of the cam, and a period of dwell for the end of the stroke. And here let us see one problem. How to draw the cam profile to give the following motion to the roller follower. Here is the roller follower. So far we have completed knife edge follower. Now onwards roller follower, right? Outstroke during 60 degrees of cam rotation, dwell for 15 degrees of cam rotation, return stroke during 60 degrees of cam rotation, dwell for the remaining part of cam rotation. So stroke of the follower is 25 mm, that is L, capital L. And diameter of the roller, here is the diameter of the roller must be there, that is 20 mm diameter of the roller. Next is minimum radius of the cam to draw the cam base circle, that is 40 mm. And the line of the stroke of the follower passes through the center of the cam axis, and outward and return strokes takes place with uniform velocity. So let us see, that means in two steps we have to complete this. One is the displacement diagram and another is the cam profile. So friends, here the angles are given to you, outstroke, dwell, return stroke, and remaining part dwell, and also stroke length is given to you, and the roller diameter is given to you, and minimum radius is also given to you. As it is not the offset follower, it is the radial follower. That's why. And the motion of the follower is uniform velocity. With this data, you have to draw a displacement diagram as well as the cam profile. Let us see this also. Draw a line equal to the, so first line, it is equal to the 360 degrees of cam rotation, one revolution, which will be represented angular displacement, and draw a parallel line, and this vertical line will be equal to the stroke of the follower or lift of the follower, and complete the rectangle. And this division on this angular displacement is the outstroke, which is equal to 60 degrees, and this will be the lift of the stroke, lift of the follower or stroke of the follower, 25 mm. And another division is the dwell period, that is 15 degrees only. And the next division will be the 60 degrees, which is nothing but the return stroke, right? And remaining 225 degrees will be the dwell period. And now divide this outstroke into same number of parts, even number of parts, that is 1, 2, 3, 4. And similarly, this also you have to divide this into same number of parts, 1, 2, 3, 4. So 1, 2, 3, 4, and vertical lines also you have to draw, right? And simply join OD, because it is a uniform velocity, will be a constant line, straight line. That's why O to D will be a straight line which will intersect one vertical line, second vertical line, third vertical line, fourth vertical line at D, A, B, C, D. And similarly here also will intersect. So 0, 1, A, B, C, D, D dash, C dash, B dash, A dash, and O dash, and remaining will giving you the uh, displacement diagram for a follower moving with uniform velocity. Draw x-axis as scale 10 mm is equal to 20 degrees to represent the angular displacement of the cam. Y-axis s is equal to 25 degrees to represent displacement of the follower or stroke of the follower, lift of the follower. Outstroke 30 mm is equal to 60 degrees. Dwell 7.5 mm is equal to 15 degrees. And return stroke 30 mm is equal to 60 degrees. And remaining 112.5 mm is equal to 225 degrees. Divide outstroke and return stroke into same number of equal parts. Join OD with a line to represent the outstroke line, and D dash to D dash with the straight line to represent the dwell, and D dash to O dash to represent the return stroke, and draw a straight line the remaining to represent dwell. The line O, A, B, C, D dash, D dash, C dash, B dash, A dash, O dash shows the displacement diagram of the roller follower when it is moving with the uniform velocity. So mark point O as center of the cam and draw a circle with the given diameter of the base circle, minimum radius of the cam, and from here, and add roller diameter as it is that means this will be the base circle. By adding roller diameter and draw another circle which is called prime circle, and here is the roller, and mark this will be the roller follower, and mark now outstroke 60 degrees from starting point A. This may be the A and this is O. From this line, this is the radial follower, and 15 degrees from this line, dwell period, and similarly, and remain next is return stroke for next 60 degrees of cam rotation. And divide this outstroke as well as return stroke into same number of parts as done in the displacement diagram. So this is 0, 1, 2, and produce up to this level. And then similarly in the return stroke also, and mark trace points at the center of the roller and draw a line. This is called pitch line, pitch curve you can say. And from bottom of the each roller, if you join all the points, you will get the cam profile. So this will be the cam profile. That is, these are the different waypoints. So friends, if you see here in this case, so this point is the cam center. This is the roller follower, sorry. And this point, center of the roller is the trace point. And this curve drawing from through the this line is the pitch curve. And this red line will be the cam profile. And this is the base circle. This is the prime circle, right? Like this, you have to draw the cam profile for the given problem when the roller follower is given to you. Draw a prime circle with O as center with minimum radius the cam 40 mm plus radius of the roller. That is, roller diameter is 20 mm and the radius of the roller is 10 mm. So 50 mm. And mark angular displacements for outstroke 60 degrees, dwell 15 degrees, return stroke 60 degrees, and divide the angular displacement during outstroke and return stroke into same number of equal parts as done in the as we have completed in the displacement diagram. And mark the points A, B, C and A dash A, B, C, D and A dash B dash C dash D on radial lines O1, O2, O3 and O1 dash, O2 dash, O3 dash, etc. to represent the displacement of the follower at respective points. And the profile of the cam is obtained by drawing a curve to touch the successive positions of the roller circumferences as shown here. So with this, you can complete your what you call displacement, both displacement diagram and cam profile for the roller follower moving with uniform velocity. Right? So in this lesson, what we have discussed, let us have a summary of this lesson. The roller follower moves with uniform acceleration and retardation. The displacement diagram is a parabolic curve. And to draw the cam profile, the follower must rotate in opposite direction to the cam. And the motion of the follower is said to be uniform when it travels in the same distance in each succeeding time intervals. The displacement of the follower is determined by the displacement of the roller center. The distance of OA is equal to the sum of the radius of the roller and minimum radius of the cam. Let us have a quiz on this lesson, for this lesson. The displacement diagram is dash during its rise and return stroke when the follower moves with uniform acceleration and retardation. The displacement diagram is dash during its rise and return or outward or return stroke when the follower moves with uniform acceleration and retardation. Cycloidal motion, straight line, parabolic, and none of the above, which is the right answer. So cycloid is it wrong. Straight line is for uniform velocity and only the remaining is either parabolic or none. So as per our discussion, this should be the double parabolic actually, but here it is the parabolic. So right, C is the answer. When the follower moves with uniform velocity, the acceleration and retardation of the follower at the beginning and the end of each stroke should be 0, infinity, finite, indifferent. So which is the right answer? Infinite. When the follower moves with uniform velocity, here is the uniform velocity is not there. When the follower moves with the uniform acceleration and retardation, of the follower at the beginning and at the each stroke is the infinite. The period during which the follower of the cam remains at rest is known as angle of dwell, angle of ascent, a dwell, at trace point. Angle of dwell is also right answer. Dwell is also right answer actually. The angle moved by the cam for the follower to rise from its lowest position to highest position. Angle of ascent, angle of descent, angle of dwell, and the pressure angle. Angle moved from lowest position to the highest position. That is simply rising, that is ascent. Simply answer should be the angle of ascent. So A will be the right answer. So here are some assignments, questions. So the first problem, draw the profile of the cam when the follower moves during both the outstroke and retrostroke with uniform acceleration and retardation. Minimum radius of the cam is 40 mm, rotating clockwise at uniform speed. To give a knife edge follower. The follower is knife edge follower, motion is uniform acceleration and retardation, and the minimum radius is 40 mm. And outstroke during 60 degrees of cam rotation, to dwell for the next 15 degrees of cam rotation, and to return its starting position during next 60 degrees, and to dwell for the rest period of a rotation. Stroke of the follower 25 mm. The line of stroke of the follower passes through the center of cam axis. So I think it is very easy for us to draw this. Simply draw the displacement diagram and also draw the, as because if it is knife edge follower, there is no prime circle, only the prime circle and base circle is same. Right? Next assignment. A cam with a minimum radius of 50 mm, rotating clockwise at uniform speed, is required to give a knife edge follower when the is required to give uniform acceleration retardation to the knife edge follower. Here is and to move outwards 40 mm during 100 degrees of rotation of the cam, then for the next 80 degrees of cam rotation, return to its starting position during next 90 degrees. This is the return stroke 90 degrees, out stroke 100 degrees, and dwell 80 degrees. And for remaining period is stationary. So this is also simple problem that you can have. Minimum radius is given to you, lift is also given to you. So thereby you can draw the displacement diagram as well as this cam profile also. Next, third problem, draw the profile of a cam to give the following motion to a roller follower. Here is the roller follower. Outstroke 90 degrees, dwell for the next 30 degrees, return stroke 90 degrees, and dwell for the remaining 150 degrees of cam rotation. The return stroke to the stroke of the follower is 30 mm, diameter of the roller is 20 mm, minimum radius of the cam is 40 mm, and the follower moves with uniform velocity. Here is the motion is uniform velocity, both during both outstroke and return stroke. The axis of the follower passing through the axis of the camshaft. It is also a simple problem. Uniform velocity displacement diagram and cam profile should be drawn. And last one problem is draw the profile of a cam to give the following motion to a roller follower. Outstroke 120 degrees, dwell 30 degrees, return stroke 120 degrees, and dwell for next 90 degrees. And the stroke of the follower 30 mm, vertical on y-axis, diameter of the roller 20 mm. To draw the roller diameter, and minimum radius of the cam is 25 mm, and the follower moves with uniform velocity. During both outstroke and return stroke, the axis of the follower passes through the cam axis. That means axis of the camshaft. So this is also a simple problem that you can draw, right? So thank you for hearing of this lesson. Thank you one and all.